Hello and welcome to another one of my Leetcode videos. In this one we'll do Leetcode 21, merge two sorted lists. So we're basically given two linked lists that are already sorted, and we need to return a merged list which is sorted. So how would we approach this? So the brute force solution is obviously to just literally combine these two lists, append one after the other, and then sort the entire list. But that would be inefficient because it would be a n log n solution. Also, we aren't making use of the fact that the lists are already sorted. Even if the lists weren't sorted, that approach would still work. So how do we make use of the fact that the lists are sorted? So a more efficient solution is we basically have two trackers, right? So we start at the head of each list, and then we compare the two elements because we know that everything to the right will definitely be greater than these two. So the smallest one has to be one of these two, right? So we pick the smallest one. In this case, both are the same. So let's say we just pick one, and then from the one we pick, we advance the pointer, right? So now our one pointer is here, one pointer is here, and so we pick the smallest one of the two. It's one, so we add one here, and then we advance the pointer of the one that we picked. And then we'd have the pointer here and here. We compare them, the smaller one is 2. And so we add that and then advance that pointer. And we keep going until we hit the end of the lists. So that is a big O of n solution because we are just traversing the list, literally. So let's go ahead and code that. So we need a tracker for list node and list 1 and list 2, but we already have these, so I guess we can just modify these pointers. And so our terminal condition will be while not, we need both list 1 and list 2 to be null, right? So that means we hit the end of both lists. So while we're not at the end of both lists, what we'll first check is, okay, if we've already reached the end of list 1, then we add list 2, right, to our merged list. Otherwise, if we've reached the end of list 2, then we add list 1 to our merged list, right? Otherwise, if both lists are present, okay, now at this point we know that both list 1 and list 2 are not null. So then we'll say if list1.val is less than list2.val, then we still add list 1. Otherwise, we add list 2. Right? So now how do we fill out these things? So now we need to keep track of the head of the merged list, right? So we'll say, okay, list node head is equal to null, and we also need to keep track of our previous node because we need to set the next of the previous node every time we identify a new value, right? So we can just have a final list node next, which we will set based on these ones. So in this case, our next is list 2, and we'll advance our list 2 pointer, right? And which is the same over here, where if list 2's value is smaller, it's the same thing. And then for this case, our next is actually list 1, and we will advance list 1 to the next pointer. And for this case, the next is also list 1 if the list 1's value is smaller than the list 2's value, and we will advance the pointer of list 1. And then at the end, what we need to do is we can say if our head is null, so if this is the first node in the list, then our head is equal to the next node that we've determined we need to add. Otherwise, we already have a head, so all we need to do is set the prev.next to the next that we've determined, right? And then in either case, we need to set our prev node equal to next. So for the next round, our prev node is updated. And so at the end, what we'll do is we'll return the head of the merged list. Need to remove the space. Cool, accepted. Let's submit. Cool. Thank you so much for watching. I'll see you in the next one. Cheers.